Now in this question we have to compare basically one time this surface is silvered and one time this surface is not silvered. When this is not silvered, you have angle of deviation, let us say delta 1, and when this surface is silvered, total angle of deviation is 3 times the previous one. Are you getting? So let us first make the diagrams. In this question, diagram is very important. So let us say first situation, that is not silvered. So this face is not silvered. So we are considering the situation when the face is not silvered. So let us say this situation, you have a sphere. So this is the sphere you have. Are you getting? And now this is sphere, let us say this is normal passing through the center. So this is the center, call this as a C, and this angle of incidence is basically 60 degree. Now if this angle is incidence 60 degree, one will expect that this reed should go in this direction, but basically this will bend, so the refractive index is mu. So this will bend towards the normal, so it will go in this direction. Now let us say this angle is r, a small r, and now this angle is deviation. So what is this deviation? This deviation is this angle is 60 degree. So this angle is also 60 degree. So this deviation is basically 60 minus r. Are you getting or not? So let us call this deviation is delta 1. So delta 1 is 60 minus r. Now let us say discuss the second surface. So you have the second surface, and now this ray will come and one will expect that this ray should go in this direction, but now this will not go in this direction because of the air, so it will go away from the normal, so this will proceed in this direction. Are you getting? Now this angle is r, so this angle has to be r. So this is radius, this is radius. Now let us say this is the normal and this is the angle of angle after the refraction of this surface. Let us call this angle is I2. Now let us call this angle is I2. This angle is R, so then this angle is also R. Now let us say this angle is deviation produced to the second surface. So call this as a delta 2, that is deviation at the second surface. So this will be, this total angle is I2 minus R. So this is I2 minus R. So what is the total deviation in this case? So total deviation in this case I will have, that is delta 1 plus delta 2, both deviation in the same direction. This also deviates in this direction, clockwise, clockwise. So both deviation are in clockwise, and that's why we are adding. So both deviation are clockwise, and that's why we can add simply clockwise. Now delta 1 is 60 minus r plus I2, delta 2 is plus I2 minus r. So this will be 60 plus I2, 60 plus I2 minus 2r. So this is the total deviation at the phase 1 in the situation number 1. Now let us discuss the second situation when this surface is silvered. Now the surface is silvered. So we'll discuss when the surface is silvered. So now this time surface is silvered. Now if the surface is silvered, what you will have, now let us make the diagram again. So this is your sphere. So let us say a sphere is this. Are you getting? Now this is the ray that is coming at an angle of 60 degrees. So this angle is given to you. So this is the center C, and this angle is 60 degree angle of incidence. Now this time this is basically silvered. So what will happen? This ray, one will expect that this ray should go in this direction, but it will bend towards the normal and it will go here. Now this angle again is a normal to this surface. So let us say this angle is R, and this angle is also r. Now this r and the previous r should be same, because at this surface there is no change. For this one there is no change, so this r and the previous r is same. So in this case this r and this r both are same, so r is same in both cases. R is same in both cases. This is important, because you see what is happening, where surface is silvering this side, there is no change in this side. So both cases this is same. Now if this angle is r, this angle has to be r. One will expect that this ray should go in this direction, but now this will not go in this direction. It will be reflected because this surface is a mirror. So let us say this gets reflected by angle r. Now this gets reflected. Are you getting? And now once it gets reflected, now at this surface there will be refraction that will take place. If nothing is goes on, this ray should go in this direction, but now this will go away from the normal, so this ray go will somewhere here. Are you getting? So this ray will go somewhere here. Now let us call at this surface, this is the deviation. This is the deviation. Let us call delta 1. So deviation at the surface number 1 is delta 1. So I can write delta 1 is equals to same as the previous one. This is 60 minus r. Now let us say this angle is r, this angle is r, this angle is r. What do you say about this angle? This angle is again r. Are you getting or not? This angle is r because radius. So let us say this is radius, this is also radius, so this angle is also r. Are you getting? Now let us say find deflection at surface 3. First discuss deflection at surface 3 and then I will discuss deflection here. So what is the deflection? This angle is r, so this angle is r. Are you getting? This angle is r. Now at this surface again we will have total angle of refraction is I2 because at this surface the things are same. If the first case you say if you have a ray that appears at angle of r, it deflects back by angle of I2. This means in this case also a ray is incident on this surface by a angle of incidence r, so it will be deflected by from the normal by a angle of I2. So this case I2 is same as the previous case. Are you getting? So let us call delta 3. So what is delta 3? So this is I2 and one will expect that this ray should come in this direction. So this ray has basically, this is the deflection. So this is your delta 3. Are you getting? So what is delta 3? I2 minus r. Same as the previous one. You see, previous one also you have delta is I2 minus r. Now let us say the second surface. Second surface is important. One will expect this ray should go in this direction, but now this ray is going in this direction. So this is the deflection. So this angle is deflection this time. Are you getting? So let me make slightly different. So this angle is delta 2. So let us say this angle is delta 2. And delta 2 will be basically 180. This angle is 180 minus 2r. Are you getting or not? This angle is r, this angle is r. So this is 180 minus 2r. Now things are easy. So what is the total deviation? So you can calculate total deviation in this case. So total deviation in this case you will have is equals to 60 minus r plus I2 minus r plus 180 minus 2r. Calculate this value. So this will be basically 60 minus r 2r, 2r 4r. So this is 4r minus and 60 plus 80, 180. Let us say 240. And this is I2 plus I2 also you will have. So you will have 240 minus I2 plus I2 minus 4r. Now the question says deflection in the first case is 1/3 of deflection in the second case. So now I can say deflection in the first case, that is without silvering, is equals to 3 times of this with silvering. Now we can solve this one. T plus I2 minus 2r. So this is 60 plus I2 minus 2r, and this is equals to 240 plus I2, and this is minus 4r. So this is minus 4r. So what you will have? 60 into 3, 180, 180 minus, so this is 60. You will have 3i2 and this goes, so you will have 2i2, and 6, this goes this side, so you will have 2r. So now I will have I2 is equals to 30 degree plus r. So this is the one expression I will have. Now let us say, now I can also apply a Snell's law. So if I apply a Snell's law at this surface, what I will have? I will have sine 60. sine 60, 1 into sine 60 is equals to mu into sine r. This is the Snell's light surface 1. Similarly, I can apply either at this surface or this surface. Both are the same situation. That is the mu into sine r. Mu into sine r is equals to 1 into sine I2. Now let us say if I compare equation 3 and equation 4, I can easily say this is equals to sine 60 is equals to sine I2. So from 3, 4 I can say sine 60 because this is same. Sine 60 is equals to sine I2. So this means I2 is basically equals to 60 degree. Now if I know I2 is equals to 60 degree, I can calculate what is the value of R. So I2 is 60 degree. So let us say if I plug the value of I2 is equals to 60 degree, then I will get mu into sine R. So mu into sine R is I2 is 60 degree. I2 is 60 degree. This means sine 60 degree is equals to root 3 by 2. Are you getting? Now you have, so let us say if you plug the value of I2 is equals to 60 degree, R is equals to 30 degree. From 1 I can write I2 is 60 degree. 60 minus 30 is R, so R is 60 minus 30, so that is 30 degree. So this means if R is 30 degree, you can calculate mu. So from this expression, sine 60 is root 3 by 2, so here you have 2. This means now from this equation you can calculate mu, that is mu into sine R is equals to root 3 by 2, and R is 30 degree. So mu sine 30 degree is equals to root 3 by 2. Now sine 30 is 1 by 2, so this is mu is equals to root 3. So in this case, refractive index of the glass surface is root 3. Important point we have, so things are symmetrical. If you does not apply symmetry, it's very difficult to solve the problem. So first thing you have to apply the symmetry. This angle is R, this angle is R, and now these two surface is same as these two surface. So if you have silvered, only one change happen at this surface. Otherwise this surface and this surface is same as without silvering.